it can't be. Can't be. Keep your mic off. Thank you. Good evening, ladies and gentlemen. Are you able to hear me? Am I audible? Okay, thank you very much. So without any waste of time, I did that intentionally. I had to join the session intentionally so that we can at least spend about 30 minutes using our own data, knowing very well that at exactly 12 o'clock or 00 hours, you'll be making use of the night hour. Because but then Zoom is not more costly as compared to Google Meet. Are you still able to hear me? I want to project or to present my screen here so that you can see my presentation. Are we still together? Okay, thank you. And if okay, let me present my screen here. Let me allow Tsepi to record the session on her side as well. Tsepi, you may record the session from your side. Yes, you can record the session from your side. And then I'm going to present my screen now so that we can continue without any waste of time. So we are looking at the probability distributions. In the previous session, we did basic probability distribution. Okay, as I was saying, in the previous session, we did basic probability distribution. It's very important for you, ladies and gentlemen, to distinguish between basic probability distribution and probability distributions. Are we together? So we have 4 types of probability distribution. So when we talk about probability distribution, we are talking about how the values of X are having their own probabilities, how the probabilities are distributed across different probabilistic spectrum. So I want to present my screen now so that you see what I'm talking about. I will try to be as slow as possible. And I think today I will be able to write using my Liveboard app. So you don't have to worry. I went through this app and okay, let me do this. Are you able to see the screen? Could you please enable the mic and let me know if you are able to see the screen so that we can continue?
Yes.
Okay, thank you very much. So we are looking at the probability distribution. Let me go to the first slide. we are all on the first slide, right? So we are looking at probability distribution. I'm not going to spend much of my time trying to explain the theoretical part. What I'm interested on is the calculations. So I want us to look at the calculations today because there are some of the things that are challenging you. But then after this session, I know you won't have any challenge. So you'll be able to respond to any question that may come in the test or in the exam or in the quiz. So I believe with all the fibers of my being that you are not going to disappoint at all. But something that is very important and that needs your attention is the issue of defining probability distribution. What do we talk about, or what are we referring to when we are saying we are having probability distribution? So they are clearly telling you there that probability distribution is a list of possible outcomes of a random variable and their associated probabilities. You will see this definition clearly when we start with the first probability distribution, which is discrete probability distribution. So with discrete probability distribution, you'll be given a table, and that table will have the values of x and the probabilities assigned to each value of x. So that table will be a clear diagrammatic representation of probability distribution. You are given the values of x and their assigned probabilities. That is probability distribution. It's a list of all possible outcomes of a random variable and their associated probabilities. So recall that when Ms. Mulauzi was still teaching you, she explained clearly the discrete random variable and the continuous random variable. So when you look at that definition, it might seem complex or it might seem complicated. So I'm going to make it simpler this way. I also explained to you what discrete and continuous probability random variables are, how they differ. So when we talk about discrete random variable, I'm not going to refer to that definition there. So make sure you take note of this. Don't miss this one out. It's very important. So the main difference between a discrete random variable and a continuous random variable is that a discrete random variable comes from a counting process. I'm going to repeat that one. A discrete random variable comes from a counting process. It means that they might say the number of boys registered for stats 012. So we can count the number of boys who are registered for this module, and then we can count them from 0 up to a positive infinity. So that is what? That is a discrete random variable because it comes from a counting process. We can count the number of those variables or the number of those outcomes or the number of whatever we'll be calculating. So it comes from a counting process. And that is why in brackets there, they are saying it's usually the integers from 0 up to positive infinity. Are we together? So if it's not clear, please make sure you pause me and I will try to re-explain. So discrete random variable comes from a counting process. You count from 0 up to positive infinity. Whereas when it comes to a continuous random variable, this one comes from measurement. We are measuring. So you cannot measure the number of boys who are registered for this module. You can only count them. But when it comes to a continuous random variable, these are the things that can be measured. So that is why they are saying it can validly take on any value in an interval, meaning that we can have between 0 and 1. So within that interval, we can get a certain value. And in that case, because we can measure that particular value or the extent or the degree of that particular value, we are saying this is a continuous random variable. I'm going to give you the example of a continuous random variable as well. The example is a height. Who amongst us in here can count height? Can you guys count height? Is it possible for you to count your height?
No, you can't, but you can measure
And
the height.
yes, you can measure the height. Very good. So it means that height, because it can be measured and not counted, it's regarded to as a continuous random variable. But if we were able to count height, we were going to say it's a discrete random variable because it comes from a counting process. But in this case, height can only be measured. Therefore, we regard it as a continuous random variable. The second example of a continuous random variable is your weight. We cannot calculate your weight. We can only measure it. So that is a continuous random variable. Make sure you know them because you are still going to write an exam. And when you write your exam will consist of Miss Mulauti's part and Miss Paho's part. So you should be able to remember everything you did before. So as I have said, we did basic probability last week and some weeks before last. So today we are going to look at probability distribution. We have 4 types of probability distribution, namely discrete probability distribution, secondly, binomial probability distribution, thirdly, Poisson probability distribution, and lastly, normal probability distribution. So it's very important for you guys to know the properties. Write this somewhere. It's very important for you to know the properties of all these probability distributions. If you don't know the properties, you are going to have a very serious problem. So the properties are the ones that are going to guide you on whether you are using Poisson distribution, binomial distribution, normal distribution, or discrete probability distribution. The reason I'm saying this is because we are going to calculate mean, we are going to calculate variance, we are going to calculate standard deviation, and we are going to calculate probabilities. All the aforementioned are calculated in different ways. So it depends on the distribution you are given. So they will never tell you on the statement the type of probability distribution you are using. They will just give you a statement and you have to identify on your own whether it follows a discrete, a binomial, a Poisson, or a normal probability distribution. So the formulae are different in each of these distributions. So it's important for you to know how to distinguish between these 3 distributions. So we are on slide number 2. So I already told you that apart from the basic probability that you know, the one we were talking about, the mutually exclusive event, the conditional probability, the independent event, and Bayes theorem, and all those things, those were just the basics of probability. Now we are doing the distribution of those probabilities. So for the purpose of our lecture tonight, we are only going to look at the 2 types of probability distribution. We are only going to look at the discrete probability distribution and the binomial probability distribution. So if we might have enough time, we might still look at the Poisson, but we are not going to look at normal distribution tonight because normal distribution needs a fresh mind. So if you are not fresh-minded, you are not grab anything when it comes to normal. So I will teach normal distribution in the next session. So for tonight, I'm only going to teach discrete, binomial, and probably Poisson. So normal distribution shall be seen in the next session. So yes, with other groups, those who were attending contact lessons, they managed to do all these 4 distributions. So for each distribution, we will define the characteristics. The characteristics are the same as properties. Properties are the same as axioms. Make sure you know these things. Familiarize yourselves with the statistical jargon. Because in the test, men might say, state the properties of discrete, or state the axioms of discrete probability distribution, or state the characteristics, or state the traits. So these words are going to be used interchangeably because they are synonymous. Make sure you don't miss anything out there. Are we still together? Are we together? Are you guys with me?
Yes.
Okay, thank you. So then we will calculate the mean as I have elucidated before. We will also calculate the variance or the standard deviation and the probability in each of the distributions. Now let's look at the discrete probability distribution. So they are saying if X is a random variable associated with a particular experiment, then a list of possible values that X assumed together with their associated probabilities is called a discrete probability distribution. Let's look at what they are saying. So I will go to this slide. I'll come back to this one. So this is what they are saying on that definition. You will be given the values of X. Do you all see the values of X? From 0 up to 4. So it's 1, 2, 3. Let me admit this one. So the values of X are 0, 1, 2, 3 for A, 0, 1, 2, 3, and 4. So each value of X has the probability assigned to it. Do you see PX in the second row there? So that is what the definition is saying. There is a list of X values with their assigned probabilities. So probability of X equals 0 is 0.25. Probability of X equals 1 is 0.38. Probability of 2 is 0.50. Probability of 3 is 0.04. Probability of 4 is 0.08 for number A, for letter A. Are we together? So it's what the definition is saying. Are you with me? And I cannot continue without your response. Are you guys with me? Am I too
Yes.
fast?
Yes.
Okay, thank you.
No, you're not.
No, you're not.
Someone is saying I'm not. So which part is confusing you so that I can re-explain?
No, it's fine. You're not fast.
Okay, thank you. We are continuing. So now I have showed you what they're talking about on that definition. So they told you that you will have a list of X values with the probabilities assigned to each value of X, and that will give you a discrete probability distribution. Now, let's look at the properties of a discrete probability distribution. So the properties are on slide number 2. I don't know where those things are because I can't see the numbers clearly. Okay, so we are having the characteristics or the properties or the traits or the axioms, 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 axioms. Axioms are the same as properties, the same as characteristics, the same as traits. So the characteristics of a discrete probability distribution. How do we tell that this is a discrete probability distribution in simpler terms? So for any value of x, the probability of that particular value of x is always between 0 and 1, both inclusive. This is a universal characteristic of all probability distribution and also the basic distribution. When I say it's a universal property, I mean to say it applies in all the distributions of probability and also in the basic probability. What I'm trying to say here is that, or what the first property is implying, is that when you calculate the probability of a particular value of x, you should always get a value that is between 0 and 1, both inclusive. So you will never get a value that is less than 0 when you calculate probability, meaning that you will never get a negative probability. We don't have such. So it also implies that there's no way we can get a probability that is greater than 1. We cannot get a value that is greater than 1. 1.01 is also greater than 1. So we'll always get a value that is between 0 and 1. So both 0 and 1 are included. So you can get 0, you can get 0.1, 0.2, or any value that is between 0 and 1, both inclusive. If it's not clear, please make sure you indicate in the chat room. Or you can enable your mic and then you talk. So property number 2, it says that the sum of all probabilities, or let's go to that table and look at the first property. So the first property says that Px, so let's look at A. Px, which is the probability of the value of x, is always between 0 and 1, both inclusive. So 0.25 is between 0 and 1. 0.38 is between 0 and 1. 0.30 is also between 0 and 1. 0.04, same. 0.03 is also between 0 and 1, both inclusive. So it means that the first property of discrete probability distribution has been qualified or has been met. Are we together? So the second property now, it says that the sum of those probabilities of x values should always be equal to 1. So when you add all those probabilities, let's go back to the table. So when you add all these probabilities, you must always get 1 for you to say this is a valid discrete probability distribution. So you will add 0.25 with 0.38, with 0.3, with 0.04, with 0.03. And then when they give you exactly 1, it means that that is a valid discrete probability distribution. And listen here, for us to say that is a valid discrete probability distribution, both properties must hold, or they must be validated, or they must be qualified, or they must apply. So if one property is applied and the other is not applied, then it means that is not a discrete probability distribution. Sure, my laptop is not charging. Okay, so as I was saying, for you to say this is a valid discrete probability distribution, both properties must be met. Are you guys with me? Do you understand what I'm saying? I don't think I'll be able to.
Yebo.
Okay, thank you. So we are continuing. Now, in the next slide, we are given the formulae for calculating the mean, the variance or the standard deviation, and the probability. So let's start with the formula for calculating mean. Mean, you write this down. I always say this over and over again. Mean is the same as average. Average is the same as expected value. Expected value is the same as expected number. It means that I gave you 3 synonyms of a mean. So mean, I'm repeating, mean is the same as average. Average is the same as expected value. Expected value is the same as expected number. So it will depend on the mood of the lecturer when she sets the question paper. So in the exam, she might decide to say, calculate the average, or she might say, calculate the expected number, or she might say, calculate the expected value, or calculate the mean. Just know they are one and the same thing. So they gave you mu. So they say mu, remember, is the population mean. And then in the first part with Miss Mulauti, we had the sample mean, which was denoted by X bar. I also gave you a table. Let me see if when I write, you will be able to see what I'm writing. So we had what? If in So we had X bar, right? I gave you a table distinguishing between the parameters and the statistics. Remember, parameter is a specific characteristic of a population, just to remind you. And then a sample is, I mean, say a statistic is a specific characteristic of a sample. So I gave you those, the population parameters and the sample statistics. You know them. So X bar is the sample mean, whereas mu is the population mean. So we are given mu. Mu is the population mean equals this E means expected. And then bracket in mathematics means of, and then X. So when we pronounce this, we will say the expected value of X. So that is your EX. Or we can say the expected number of X equals EXI PXI. So it means that when you calculate mean of a discrete probability distribution, you will find the product of X with its probability, and then you add all those X values, the product of X values with their assigned probabilities, then you will get the mean. Are we together? Are you guys with me?
Yeah.
Okay, thank you. So let's look at the example. Let's calculate the mean using this example. But let's not do it now. Okay, yeah, let's make an example. Let's use A as an example. So don't look at this question here. Let me go to annotate again and remove this. Yeah, this thing is slow. So when you calculate the expected value of X, are you able to see my pointer? Are you guys able to see my pointer?
Yes, we see that.
Okay, thank you. So where I'm pointing at, so you will see a vertical line which runs from here, and then a horizontal line which runs up to there. So if you look at it clearly, you will see that this is a plus sign, isn't it? Do you see that this is a plus sign? And then even here, we have a plus sign. Do you see what I'm talking about?
Yes.
Okay. So it means that when you calculate mean, they are saying mean is E, that sigma is sigma of X. You take the value of X, you multiply by its probability. So it means that we will take the value of X multiplied by the probability, we add the value of the second value of X, you multiply by its probability, plus the third one, multiply by its probability, plus the third one, and so forth and so forth. Do you understand? So it means that when you calculate mean for A, we will say 0 times 0.25 plus 1, because 1 is the value of X as well. 1 multiplied by 0.38 plus 2 times 0.30 plus 3 times 0.04 plus 4 times 0.03. And then you get the answer. That will give you your mean. Do you understand? Okay. So let me increase the volume here.
No, we don't understand.
You don't understand. Let me explain again. So this is the formula. Hello? I can't hear you clearly.
Anginikeza u-350 lo baba mfethu. Yabo.
What?
Lencane lo ukuze ngithe bangene lapha ngabona ukuthi hayi.
Who's talking in isiZulu or isiXhosa or Siswati?
Mangitshela ukuthi usazohamba ayothenga something.
Amen. Let me see what I can do.
Manje hayi cha ngizohamba ngiyothenga okuthile.
Ziphathe kahle, you are disturbing us. I'm gonna mute you.
Sorry.
So let's continue. So this is the, where am I? So this is the formula for calculating mean. This one, right? So it's the formula for calculating mean for a discrete probability distribution. It means that you will take the value of X, you multiply by its probability, you add the second value of X, multiply by its probability, the third value of X, you multiply by its probability. So in terms of our table, so we have this table, the first table. So you will take the first value of probability, which is 0, is X. You multiply by Px, which is the probability of X equals 0. So 0 times 0.25. And then because of that sign, yes, sigma, that E, so you will say plus, which is here. It's here. Your plus sign is here where I have pointed. Plus and then 1 is the second value of x times its probability, plus the third value of x is 2. So 2 times its probability, plus the fourth one, 3 times its probability, and so forth. So the sum of the product of the values of x and their probabilities is the expected value of x. Do you understand?
Yes, ma'am.
Yes.
Thank you. We are moving on. So let's look at the second formula. The second formula is for calculating variance. Be careful here. When you calculate variance, remember we have already calculated the mean, right? So you know the formula for calculating mean, which is your mu square, which is your mu. So this is your mu. The formula for calculating your mu is here. So it means that you can take that formula, you substitute it here, and then you square it. So when you calculate variance, which is sigma squared, it will be equal to square bracket. So the sum of xi squared pxi in brackets, and then you subtract mu squared. So you are going to follow the same method you were using when you were calculating mean, but the difference is that you are going to square the value of x. So you square the value of x before you multiply by its probability, and then you add the second value of x, you square it, you multiply by its probability, plus the third x, you square it, you multiply by its probability. And then after that, you get the sum of those, right? So that will be your squared deviation. And then you subtract your mean squared. So let's look at an example, A again. So when you calculate that, the part that is in the square bracket, which is ex squared px. So you will take the first value of x, which is 0, you square it, and then you multiply by its probability, which is 0.25, plus the second value of x is 1. You say 1 squared, you multiply by its probability, plus 2, you square it, you multiply by its probability. 3, you square it, you multiply by its probability. 4 plus 4, you square it, you multiply by its probability. You get the answer. So the answer that you get will be for this part, the part that is in the square brackets here. Are we together?
Yes.
Okay. Then after that, after finding the answer that is in bracket, you subtract that answer by the mean which you calculated before using this formula on top here. So you subtract by mean squared. So you put that mean in bracket, you square it, and then that will be your variance. Are we together?
Yes.
Thank you. So in order to get the standard deviation, you will just introduce the square root both sides. So you take the square root of this formula here, the whole of this, then you get the standard deviation. Very simple. Do you see? So now we are looking at the formula for calculating probability. So if you don't understand, please make sure you enable your mic and then you stop me. I will listen to you and then I will re-explain if it needs re-explanation. So I'm not a lecturer, I am a mentor. Mine is just to make you understand the concept, to make you understand the procedure so that you can pass your test with distinction. So we were supposed to be, yes? So
Ma'am,
did you want to say something?
no, ma'am, sorry.
Okay, thank you. We are continuing. So when you look at the last part on this slide, they are saying there is no formula for calculating the probabilities. There is no formula for calculating probabilities. The values are taken from the table. This is what they are saying. But the formulae for calculating probabilities are actually there. So you will see what I mean when we do calculations. There are formulae for calculating probabilities. So let's continue. We are going to slide number 6. Then I will give you the formulae when we do calculation. Yes, you get the answers from the table, but then you will need to come up with your own formula. So the formulae are there. There's no way you can calculate probability without the formula. So which of the following is example number 1? Okay, yes, I'm sorry. Which of the following is or are valid discrete probability distribution? How do you think we are supposed to answer this? What are we supposed to check if this is indeed a valid discrete distribution? Anyone?
Ma'am, you say that there must be in between 0 and 1, and once you count all of them, they must add up to 1.
Thank you. Yeah, you are right, but I want to rectify something. So we said, you must say this. For us to say this is a valid discrete probability distribution, the probabilities of X should always be between 0 and 1, both inclusive. Secondly, when you add the probabilities of X values, these probabilities, you must always get 1. Do you get it?
Yes, ma'am.
Thank you. It means that we are going to look at the properties of discrete probability distribution. They are only 2, and they are the ones that you have given to me. So if any of these does not meet those 2 properties, then it's regarded to as an invalid discrete probability distribution. So let's look at the first one. Is it a valid discrete probability distribution?
Yes.
Okay, let me, is it a valid discrete probability distribution?
Yes.
Okay, Kanisa Consentia is saying yes. Do you all agree? Do you all agree that this is a valid discrete probability distribution? So,
Yes, ma'am.
okay, you add the probabilities. Do they give you 1? I don't have a calculator with me. But then if they give you 1 and the probabilities are between 0 and 1, then it's a valid. Are we together? So secondly, you said, I don't have a calculator, so I will just hear from you. So you said this one is valid. So B, is it valid?
No.
Meaning that it does not meet one of the properties, which is what? Which property is not met? When we check the values of probability, they are between 0 and 1, right? The first property has been met. But when we add the probabilities, do we get exactly 1?
No.
Okay, then it's invalid. The third one, is it a valid?
No.
So you check the probabilities are between 0 and 1. When you add the probabilities, you must always get 1. So it means that you did not get 1, right? So D, is it valid?
Yes.
Okay. Then it means that A and D are valid discrete probability distribution. Any question? Without a question, we will go to the next slide. For any valid discrete probability distribution, very important. For any valid probability distribution, calculate the mean and the variance. So you don't have to calculate the mean and the variance for everything. You only calculate for valid discrete probability distribution. Are we together? And the valid probability distribution were A and D, isn't it? So it means that you calculate the mean for A and for D. You also calculate the variance for A and D. Are you with me?
Yes.
Okay, thank you. So will you fail to do that?
No.
Okay, thank you. So if there's any of you who will fail to do so, please feel free to enable your mic and let me know. So if you won't fail to do so, it means that we are continuing. I showed you how to calculate mean. I also showed you how to calculate variance. So you just follow that procedure and then you will never go wrong. So we are on this slide now. The probability distribution of absentee record for stack 011 students is given by that table. Before everything, we are supposed to check if this is a valid discrete probability distribution before we use the formulae for discrete probability distribution. Is this a discrete probability distribution? Does it meet the two properties? Are these probabilities between 0 and 1, both inclusive?
Yes.
Thank you. When you add the probabilities, do you get exactly 1?
Yes.
It means it's a valid discrete probability distribution. So we are going to calculate probabilities. Now I have to present using this other form. So make sure you have this, take a screenshot of this because I'm going to present using my other device now because I want to present using a live board so that you see what is happening. Or let me just write, even though it might take me long. So I can't see my board. So I will have to present using this other device. So any question while I'm trying to join your session with a cell phone? Any comment? I'm trying to join using this phone. So if you have something to say, feel free to do so. Yes, I have joined. Let me see if I can. asked to start a video. So what will happen? I don't know what will happen if I make myself a host in this device. Let's just pray for it. So, yeah. This will stop other, okay, other screen sharing. So like I said, please make sure you have a screenshot with you that side, the screenshot of that problem. Sure. I want to look at the questions as well. So, or let me take a picture here. So that you can see. Are you able to see the picture?
Yes, ma'am.
Okay, thank you. The probability distribution of the absentee, we have already checked if this is a valid discrete probability distribution. Now we are going to find the probability that A, exactly 3 students were absent. So when they say exactly 3 students were absent, they are saying you calculate probability of X equals 3. So you will take this from your table, right? You go to your table and then you go to 3. So your 3 is here. So that is exactly 3. So what is the probability? What is the probability of X equals 3?
0.25.
0.25, good. So it's 0.25 and then you will get a mark. So B, they are saying, let's check question B. At most, 2 students were absent. So this takes us back to the issue of at least and at most. So I said, when they say at most, at means equals to. So you say at, I'm using a different color. So it's at, and then most in statistics or in math means less. So at is equals to, and then most is less. So meaning that at most is less or equals to. Are we together?
Yes.
So it means that they need the probability of X less or equals to 2. That will be your at most. So it means that you will take all the values, that the values of X, the probabilities of X equals 2 going down. So it will be, you go to the table, so at most will be here. 2 is included. So you add these probabilities, you will get the probability of at most 2. So it means that is probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2. So that is at most. And then you check on your table. What is the probability of x equals 0? 0.025, isn't it? So it's 0.025, and then you add the probability of x equals 1, 0.175, right? 0.175 plus the probability of x equals 2, which is 0.125. 0.125. You add all these probabilities, you will get a value that is between 0 and 1, both inclusive. So even here, 0.25 is between that interval. So even here, you are supposed to get a value that is between 0 and 1, both inclusive. If not, then we call it a night. We shall meet again next year. Okay. So you should always make sure that when you calculate probability, your value is always within that interval. If you get a value that is maybe 1.25, it's not a probability. You should start from scratch. So you start afresh and then you calculate until you get 0 point something or 0 or 1. But it should be between 0 and 1, both inclusive. Did you get it?
Yes.
So we are now looking at an alternative. So there is an alternative way of calculating this. Here you must listen very carefully. It's important for you to know the alternative, because when it comes to Poisson distribution, they will give you at least something. So they will say calculate the probability of x at least this. And when it comes to Poisson, we don't have, they are not finite. The values of x are not finite. They don't give us the value of n. So it means that we will not have an endpoint. So if they say at least, let's say maybe they say greater or equals to 6, it means that they are saying 6 or any value that is greater than 6. So it's 6, 7, 8, 9, 10, up to positive infinity. So you will not know where you are going to end. So infinity is not known. Even the people who came up with numbers, they don't even know what infinity is. So infinity is just something that is not known. It's just a mystery. So I'm using an alternative way of calculating this. That was the null. The method we used, it was a null, right? Now we are using an alternative. Listen attentively here. So we can calculate the probability of x less or equals to what? It was x less or equals to 2. Equal. So when we say this is an alternative method, we expect to see 1 minus. Very important. So for you to tell that this is an alternative method, we expect to see 1 minus. Always. Are we together? So those who attended contact lessons will tell you they know very well. So when we say this is an alternative, you should always include 1 minus. Always, don't miss it out. And I always make use of a different color so that you see that I'm overemphasizing this. So how do you get an alternative? So let me use my color again, which is green. So the probability of x, right? So the probability of x, and then for you to get the alternative way, you are going to pretend as if you don't see this equal sign here. Let me use a different color. Look at your left-hand side. You hide that equal sign, right? Are you with me? You use your finger and then you hide it. It's just that even if I can use a finger, you cannot see me hiding it there. So I will just circle it to show that I am hiding it. Again. So you hide it, and then after hiding it, you change that sign that is remaining there. What is remaining on your left? Which sign is remaining on your left? Which sign is remaining on your left? Is it less than, greater than, or what?
less than.
is less than. Therefore, you are going to change it to greater than. So it means
Greater
that
than.
we will have greater than 2. So this is an alternative. Are we together? But on the left, that equal sign, we have hidden it, but we have hidden it so that we can get an alternative. I get. So when we use this formula, we'll get the same answer as the one we got here. I get. Let's prove it. So it's 1 minus the probability of x greater than 2 in brackets. So it will be any value starting from 3 because 2 is not included. I get. Do you understand?
Yes.
So it means that we will start from probability of x equals 3 plus probability of x equals 4 plus probability of x equals 5 until probability of x equals 6. And then when you punch on your calculator is very wise. It's going to apply BODMAS rule. So it means that it will start with bracket. So it will calculate what is in your bracket, right? And then after that, it takes the answer from the bracket, it subtracts it from 1. And then you will get the same answer as that one here. So you will add what? So greater than 2 is what? They start from 3. They are these ones. So 0 0.25, 0 0.225, 0 0.125, 0 0.075. So you add all these values, you subtract them from 1, you will get the same answer as when you add these ones here. Do you get the same answer? Shoot.
Yes.
You got the same answer, right? You got the same answer, isn't it?
Yes.
Yes.
Okay, thank you. That is important. Again, make sure you know the alternative, you also know the null. If you don't, you are going to fail. You are going to fail because it's important as a mathematician to know the shortest way of calculating things. You are supposed to know the shortest method. That is why you are doing mathematics. That is why you are also doing economics in our school. So as an economist, you should be efficient. When we say you are efficient, we are saying you spend less time to produce, you use less resources to bring about more output. You spend less energy to bring about more output. You use less resources. You see, as a mathematician, that is why you are doing mathematics. So the shortest route is always the best. You know the null, you also know the alternative, you will never go wrong. So I suppose you understood the alternative and the null. So let's look at the other question. Question C, at least 4 students were absent. At least means what? I said at means greater than. I mean to say equals to, right? And the least in math means greater than. So that is why when you say, I always give this practical example. I always say, you will hear someone saying, "Ish, at least I have passed." So what that person is meaning or is implying is just to say, when someone says, "At least I have passed," you don't have to ask questions. At least means greater than or equals to. So it means that that person got 50 or above because of at least. So as a mathematician, you don't have to question that person. As long as the person said, "At least I have passed," at least means greater or equals to. So from today onwards, you should jargonize statistically. You should use a statistical jargon. Are we together?
Yes.
I don't know. Are you? Are we still together?
Yes.
Are you guys able to hear me?
Yes.
Hear you.
Okay, thank
Yes.
you.
Yes.
So I said at least, you understood the at least part, right? So now they are saying at least what, 4. So the probability of x greater or equals to 4 equals, and then you will take from 4. 4 is included. So it's probability of x equals 4, probability of x equals 4. What? Probability of x equals 4 plus probability of x equals 5 plus probability of x equals 6. So you add all these probabilities, you get them from the table, right? So it's your 4, 5, and then 6. You add these probabilities, you will get the answer. Are we together?
Yes.
Yeah,
Yes.
so with an alternative, let's look at the alternative. So probability of x greater or equals to 4 equals, what did I say about at least? What am I supposed to see? What am I supposed to see?
Equals to or more.
Equals to or more. Thank you. But what do I see after equals to? To tell that there is this thing that shows that here you are working with an alternative. What is it that I have to see that here you are working with an alternative?
1 minus.
-1.
1 minus. Good. You are ready. Tomorrow I'm writing an email to your lecturers. I will tell them that they should just give you a test. You are ready. So it's 1 minus, right? Very important. So 1 minus, and then you are going to hide this. You pretend as if you don't see the equal side, right? And then you
Yes.
change this. What do we have on the left-hand side? Which side do we have? Greater than or less than?
Greater than.
Greater than, right? And then we change it to what?
Less than.
To less than. Good. So it will be less than 4 equals 1 minus, and then in brackets we are going to have probability of 4 is not included. So it means that we take all the values that are less than 4. So these are the values, right? So it's probability of x equals 3, x equals 2, x equals 1, x equals 0. You add all of them together, and then you will get the answer. After adding them together and you get the answer, you subtract that answer from 1, and then you get the same answer as this one. Are we together?
Yes.
Is it difficult?
No.
No, it's not. So question D, they are saying between 1 and 5 inclusive students. So between 1 and 5 inclusive students. So this is what they mean. Probability of x between 1 and 5 students. Inclusive means you include 1 and 5. Are we together? So inclusive comes
Yes.
from include. So 1 and 5. So this is 1 starts here and then 5 starts here. So 1 and 5 are included. So you add all these probabilities here, you will get the answer. Do you understand?
Yes.
So what now when you use the alternative, I get, so when you use the alternative, you will say probability of x1, 5, both inclusive, is equal to 1 minus, you go to the table again. You check the values that were not included within that interval. Do you see them? So the first one is 6, the second one is 0. So you add them together, those values, and then after that you subtract their sum from 1. So you subtract them from 1, and then you will get the answer. Do you understand?
Yes.
Yeah, and that answer will be the same as that one. Remember, an alternative is just the same as a plus a, this equals 1. So the complementary rule, when you calculate a complement of an event, it will be equal to a complement. A complement will be equal to 1 minus probability of a. Do you still remember? And I even gave you 2 types of commodities as an example. So, or 2 types of goods. I used tea and coffee as complementary products. So when you consume tea, I mean to say coffee plus sugar, you derive maximum utility, which is 1, is 100%, right? So for you to calculate the complement of coffee, which is sugar, you make it the subject of the formula, and then you will get the answer, 1 minus that one. So I used that example that day, so I hope you understand. So the other question, more than 6 students, you go to the table. So do we have more than 6 students on the table? Do we have any value that is more than 6?
No.
No, we don't have. So probability of x greater than 6 is equal to 0, because there are no values that are greater than 6 here. Do you see? Or alternatively, you can use an alternative. So with an alternative, you will say probability of x greater than 6 equals. For us to see that you are dealing with an alternative, we expect to see 1 minus. 1 minus. So another thing that is important is that if on your left here, you did not have the equal sign here, right? On the right, you are supposed to have it. So when you get the alternative for this, you are supposed to say probability of x, you include the equal sign because it was not there on the left. And then you change this sign, you make it less. So it will be less or equals to 6 equals. So you get the same answer as this. So it will be 1 minus the values that are less or equals to 6. 6 is included. You go back, you will see. So 6 is equal to 6, and then less, you add all these values. 1, you add this one. What? 6 or less. So you add this one, this one, this one, this one, this one, this one, and this one. So remember, the sum of all this was 1, right? So 1 minus 1 is 0. Do you see that the alternative is still the same?
Yes.
So we are done with Poisson distribution. Let me go back and make myself what? Let me see. Is it this one? No. And then who is the host? These accounts are confusing me now. Yeah, okay, I see. Let me switch my mic off this side. We are still together. So it means that we will not do Poisson today. So we'll just do another, the last one, which is binomial. Are we still together?
Yes.
Are you with me? Okay, thank you. We are moving to the second probability distribution, which is binomial distribution. So the word by or the prefix by in Shell, Miss Mperwani and her team taught you of affixes. So affixes, we have a prefix and a suffix. So a prefix is the one that comes before. Pre means before. So by is a prefix here. So a prefix by, whenever you see a prefix by, know that it talks about two things. By means two. And then nomial means number. Nomial in Greek. So nomial means two. So I think I will have to present again this side, but you understand, let me not present. By means two, nomial means three. But then I like explaining things that people can see. So let me rejoin and write as I'm explaining. So I am making this one a host again so that I can write. Or let me see, to avoid doing this over and over again. Rapid technology, you have to be patient. Okay. Host disabled this one from. Is it not possible for me to make myself present even though I'm not a host? I can't see. Okay. I am making myself a host again. Yes, and please don't mind the messages that pop up on my screen. So I am going back to my Liveboard app. So when we talk about binomial, as I have said, make sure you listen very carefully. Isn't it that I taught you how to identify a discrete? So they will never tell you that this is a discrete probability distribution. You have to identify it on your own by looking at its properties. They are only two. Probability lies between 0 and 1, both inclusive, always. Or the sum of all those probabilities should always be equal to 1. So So by means 2, as I have said. Nomial means number. So meaning that when it comes to a binomial theorem, you will be given 2 numbers, and those numbers are n and p, where n is the sample size, p is the probability of a success, right? So first things first, you read the statement. After reading the statement, you realize that you are only given 2 numbers, and those numbers are the value of n and the value of p. It tells you that that is a binomial distribution or a binomial theorem. Are we together? Are you with me?
Yes.
Okay, thank you. And then I am explaining further. We are not done. So you will be given n and p, remember. So n is the sample size, not the sample space. The sample size, p is the probability of success, meaning that if something is successful, we can have what? A failure. So a failure is denoted by q. And how do we calculate this? The probability of a failure, we just subtract p from 1. So you'll be given p, and then you subtract it from 1, you will get your failure, right? Make sure you write that down somewhere as well, because it will be needed as we continue. So the other thing that is important for you to know in this theorem or in this distribution is the issue of what? I wanted to say something and I forgot. Okay, remember, probability is the same as proportion. Proportion is the same as percentage. I remind you of this every time. In my session, there's no way we can do probability without me saying something like this. Probability is the same as proportion. Proportion is the same as percentage. So they all start with P, 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 therefore P. So meaning that if you read a statement and you realize that on the statement you are given a percentage, that percentage is your P. So the other thing you have to note is that P, since is a probability, can never exceed this interval. It can never go beyond this interval. Even if they say 20%, 20% means 20, and I told you that per means divided by cent 100. So 20% is 20 over 100. 2 over this one and this one, and then 2 over 10 equals 0.2. Therefore, 0.2 is still within this interval. Do you see? Therefore, there is no way the value of P can exceed 1. Very important to note as well. I hope that your notebook is now about to be full, because I've been giving you a lot of points you need to note in each and every distribution. So that is very important. So same applies to the value of Q. Remember, the value of Q is also a probability. So Q, what? Q, king. So, Lena, yes. What's happening? Q is the same because the probability of a failure. So it will also be between 0 and 1, both inclusive. And never write a number on top of a number. If you make a mistake, you erase and then you start afresh. 0, and 1. Are we together? So the other important thing you should note when it comes to binomial theorem is that we have n combination x, which is the same as ncx, which is the same as n factorial divided by x factorial multiplied by n minus x all factorial. Are we still together? I need your responses. Are we together or you are sleeping?
We're together.
I will finish very soon, don't worry. By 2 o'clock I will be done. So n combination x, we call this please. When you see something like this, you don't say nx. What is nx? This is n combination x. And then same applies here, ncr. This is n combination x. And then it's the same as this here. So when you go to your calculator and you look at your division sign, on top here, what is written on top of your calculator here? On top of the division button.
And combination R.
Good, is NCR. So R is the same as X, right? So it's N combination R. They wrote NCR. But if you look at the multiplication side, what is written on top will be NPR. So your P, don't say this is N probability R. That is not true. This P denotes what we call it denotes what we call permutation. So it's N permutation R or N permutation X. Whereas that one with a C is N combination R. Now I want you to prove that this N combination R, okay, something that is important as well. There's no way the value of N can be less than the value of X. So N is on top and it will always be greater than X. So it will either be greater or equal to X, but it can never be less than X. Even if you punch it on your calculator, it will show you that this is undefined. So that function is undefined. So the value of N will always exceed the value of X. And I'm telling you what you're supposed to expect. So when you do calculations, we'll just polish and pass by again. So the value of X, you always get the value of X. Very important as well. Write it somewhere. The value of X is always given on the question, whereas the value of N is from the statement. So you will get the value of N. These people are disturbing. The value of N and the value of P, they will be given on the statement, whereas on the question, you'll be given the value of X. Write it somewhere. It's very important. So the other thing, I think they are all. So now I want us to check if indeed those three are the same. So we are saying 5, let's say the value of N is 5 and then X is 3. So you are going to press 5C3 on your calculator. You press 5 and then you press shift, you press division sign, then C will pop up on your screen and then you write 3. And then at the end you have 5C3 and then you press equal sign. What is the answer?
10.
Good. The answer is 10, right? And we want to check if these two are the same as n factorial divided by x factorial into n minus x all factorial, right? So we got 10 as an answer. So please make sure you keep it in mind. So remember, the value of n is 5 and the value of x is 3. So I'm going to the next page. So we substitute on that equation of n factorial over x factorial into n minus x factorial. No? So it will be x all factorial, right? We are substituting. The value of n is 5 factorial divided by x is 3 factorial. 5 is n minus 3 and then factorial. So this sign is also there on your calculator. You press shift. I don't have my calculator with me. I don't know. But then I think you will press 5 and then for you to get this sign, you will press shift and then you press the second button after the second last button before the on or the power button. So if this is your calculator, so this will be your on button, and then before your on button, you will have this one, and then beneath this button here. So you press shift and then you press this button. So that will appear. Is that the correct one? I don't know. I don't have a calculator with me, but it's there on your calculator. So, and then you substitute 5 this side divided by 3 this side, you multiply by 5 minus 3, you will get the answer. But we can still do it manually. 5 factorial means 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1 into 5 minus 3 is 2, and then factorial, which is 2. 2 factorial is 2 times 1, right? And then at the end, 3, 2, 1 and 3, 2, 1 will give us 1. So we remain with 5 times 4 divided by 2 times 1. 5 times 4 is 20. Divided by 2 times 1 is 2. 20 divided by 2 is 10. Therefore, we have proven that this is the same as. So we have proven that this is the same as n combination x and ncx. Did you get it? Did you all understand? Should we continue?
Yeah.
Thank you. I'm happy you are still energetic. I need vibrant students. So we are continuing. Yeah, I have introduced all the important things to you, right? But the last one is when you calculate probability of x equals a particular value, right? The answer will be, so this is the general formula. So you will have your n combination x, and I taught you how to calculate this, multiplied by your p to the power x, and then your q to the power n minus x. So this is the general formula. You are supposed to know it. Again, so I told you that p is given from the table. I mean to say from the statement, x from the question, n from the statement, and then your q is 1 minus p, right? So we are just going to do substitution. Are we together? So let me do this. I'm going to this slide. I have explained everything there. So I'm going to skip those characteristics. But before I skip them, let me explain something there. So are you able to see the slides from your side, even if I don't project? Because I am avoiding going that side using the PC and coming this side using a phone, and then over and over again. Do you have the slides with you that side? I have sent them via WhatsApp. Do you have them with you, or I should present?
Presentable.
Okay, let me leave the session here. But before that, I will need to make my other account a host. Are you still able to see my screen, the other screen? Because I can see when I look at this phone, it's but let me where am I? So this is where we are. Are you able to see my screen now? So I'm gonna explain the first and the second one. Those ones I have already mentioned, but I just want to clarify something there. So they are saying the characteristics of the properties of a binomial distribution. It has got two mutually exclusive. So I told you about mutually exclusive. I even asked you a question about you and your partner. You all have boyfriends, you all have girlfriends. So when we say you have a mutualistic relationship, we are actually saying you are benefiting from each other. You did life sciences in grade 11. They taught you about parasitic relationship and mutualistic relationship. When we say you are in a mutual relationship, you are dependent. I mean to say you meet each other halfway. So there is an intersection in your relationship. So, and then exclusive means without. So meaning that if these events are mutually exclusive, and I said mutually means intersection. So it means that these are the events that are without intersection. They don't have common outcomes. They don't have common values. So they are mutually exclusive. They don't have intersection. And when they say they are collectively exhaustive, they are trying to say the sum of their probabilities is 1. So when you add the probability of a success with the probability of a failure, you must always get 1. Is that clear? So mutually exclusive means without intersection. And then collectively exhaustive outcomes means that these outcomes do not, I mean to say, their sum, the sum of their probabilities is 1. Did you get it? So it means that when you add the probability of a success with the probability of a failure, you will always get 1.
Yeah.
Good. So each outcome has an associated probability of success denoted by P. I've already touched on this, so there's no need for me to overemphasize it. So yeah, let me go back to my device now so that I can explain while writing. We are almost done. So we'll be done in by 20 past 1. We'll be done. Oh. I'm joining. So as I have said, by 20 past, we will be done. And lucky enough, you will get the recording. And then I am supposed to make myself a host this side again. No, there's no need for me to do this. But let me just save it. What I needed were the questions. So we are only gonna do this question, and then the rest will be your homework. So when you calculate mean, when it comes to binomial theorem, am I still audible?
Yeah.
Okay, thank you. So when you calculate mean is the same as expected value of x. No. When a laptop waras, so mean is the same as the expected value of x, which is the same as mu equals. So when you calculate mean for binomial distribution, you take n, you multiply by p. So where do you get this to? From the statement, right? Simple and straightforward. When you calculate your variance, which is sigma squared, population variance, remember the table, the difference between sample variance and the population variance, you should know that. So population variance is given by your n multiplied by p multiplied by q, which is the same as np, and I told you that q is what? Q is 1 minus p. So these formulae are the same. So when you calculate standard deviation, you just introduce square root both sides, and then you will get the correct formula, which is the square root of np 1 minus p, which is your q. I hope we are together. So I want us to look at the question. So remember, We said for each distribution of probability, we are going to calculate mean, we calculate variance, we calculate standard deviation, and also the probabilities. Now, we have this question here. We are reading it together. A textile firm found from experience that only 20% of the people applying for a certain stitching machine job are qualified to work. Full stop. The definition of statistics says this is a science of collecting data. We analyze the data, or before we even analyze, we collect the data, and then we group it, or we arrange it in order, and then we summarize those steps. You know all of them, I get. So, but the first step is collecting data. So when you read a statement, make sure you collect data. So this is a full stop here on the first sentence. We saw a number and we are interested on that number because we are statisticians. So as statistician, you must have an interest. Whenever you see a number, develop an interest, and we are given a percentage, which is 20%. So what does this number denote? Is it the value of n, the value of p, the value of x, the value of what? What is it denoting there?
The value of
P.
Good. You are ready. I said percentage is the same as proportion. Proportion is the same as probability. Therefore, you are given P as 20%, which can be expressed as 0.2. Then our P is still between 0 and 1. Therefore, we are certain to infer that this answer is indeed true. Add 100% confidence interval. Do you see? Next week we'll be doing confidence interval. Now let's go back to our statement. So we have read the first part. 5 people were interviewed. So we have another number there, which is 5. What does it denote?
N.
Good. The value of n equals 5. And therefore, the statement is complete, right? Therefore, we have the questions. Before we go to the questions, how many numbers are we given? From the statement, how many numbers are we given?
2.
2. So 2 means by, isn't it? Numbers mean nomial. So it's binomial, isn't it? And before you can say it's binomial, you should check if you are given 2 values, and those 2 values are the value of n and the value of p. Therefore, you can infer at 100% confidence level that you are working with binomial distribution. So you can calculate the value of q from there before you do all the things. So the value of q is given by 1 minus p. And then 1 minus p will be 1 minus, you have your p, which is 0.2. So it's 0.2 equals 0.8. Let's prove if indeed these two are collectively exhaustive. So remember, I said collectively exhaustive outcomes are those whose probability, the sum of the probabilities is 1. So when you add 0.2 with 0.8, you get what? You get 1. Therefore, these outcomes are collectively exhaustive. Are we together? So we have P, N, and Q. Before they ask us to calculate anything, we can calculate mean. Mean is the expected value of X, which is your mu, equals NP. You have your N, which is 5. You multiply by your P, which is 0.2. And then you get the answer. What is the mean? 5 times 0.2, the answer is
1. 1.
And then you can even calculate sigma squared, which is NPQ. You have everything equals N is 5, P is 0.2, and then our Q we calculated it, we got 0.8. What is the answer?
0.8.
0.8. So this is your variance. And then your standard deviation, which is the square root of NPQ, equals the square root of N is 5. You multiply by your P is 0.2, your Q is 0.8. What is the answer?
0.894.
894. Remember, in statistics, we always round off to 4 decimal places. Very important. So we have calculated those. So if they ask us, we will just take the values from there, we copy and paste. Okay. And then we go back to the question. Find the mean and standard deviation. Mean and standard deviation. So we have calculated them. Okay. So this is your mean, and then this is your standard deviation. Then you get the max. Okay. So are you with me or I'm too fast?
Sisoge, yeah.
Thank you. And then we are on question B. What is the probability of finding at least 3 qualified persons? At least means what? So it will be at least means what? At least.
Discrete.
Equal, equal to.
Lena ba gore less or equals to. Lena akere. Ke mang a rileng less or equals to? Ona le lucky, you did not repeat. We get over 1 lash. So at least I said least in statistics is greater than. At is equals to, therefore at least, at least. So it will be greater or equals to. Never confuse the two. So it will be greater or equals to, they said at least what? 3. It's at least 3, yes. So at least 3. We denote it like this. Therefore, it means that you calculate probability of what? X equals 3 plus probability of, no, it's plus, not multiplied by, plus probability of X equals 4 plus probability of X equals 5. So 3 is included in this interval because there's equal sign here. Are we together? So you can calculate for me. So you are going to calculate. I gave you the formula, right? For calculating the probability. The general formula for binomial is this one, right? So you will take each value of X, you substitute it here. So you start with the first one. Probability of, you go to that formula again. So you start with the first X value. So it's probability of X equals 3. Therefore, it will be equal to what? You calculate using this formula. You calculate and give me the answer. What did you get?
0,0512.
0,0512. Did you understand the procedure, everyone? So it was for the first value of x. Okay, let me explain. We are going to use this formula. Again, I'm not going to erase it. So I hope you wrote the value of n, the value of p, the value of q down. So we are just substituting now. So we are calculating probability of x equals 3. It will be equal to, the value of n is 5. The value of x is what? This is the value of x. And I told you that you will always get it from the question. It's 3. Your p is 0.2 to the power x, which is what? Which is your 3.
3.
Multiplied by your q, we got 0.8, right? So your n is 5. You subtract 3. You get the answer. So you punch this on your calculator. You know how to calculate this. I showed you how. Again. So you press 5, you press shift, you press division button, and then C will appear on your screen, and then you press 3. You put it in brackets. The whole of that is in bracket, and then you open another bracket. 0.2, you close the bracket, you cube it, and then you open another bracket. 0.8, you close, and then 5 minus 2. What do you get? What do you get?
0.0512.
0.0512. Thank you, Kanisa. Kamorelo, what do you get? Salda and Proud.
I got 0,0512.
Okay, yeah. But then the numbers after a comma, we call them individual. Again, we don't say 0.512 or 0.512, 0.0512. If you call it like that, then mathematicians will kill you. Again, so the numbers after a comma, we always pronounce them, we call them individual. Again, 0.0512. So I assume you all got the same answer. I get 0.0512. Therefore, this is not the final answer. Remember, you are going to take this value. You put it here. It's for the x equals 3. 0. Equals 0.0513 plus, and then you calculate for x equals 4. Don't erase what you have on your calculator. Again, you are just gonna change the value of x. You go back to that formula. So on your calculator, don't erase anything to save time. Even in the test, you don't erase. You just change this value here, you put 4, and then here you put 4, here you put 4, here you put 4, and then you get the answer. Do you get what I'm saying?
You.
You don't. Isn't it that we calculated the probability of x equals 3, and then probability, let me write probability of x equals 4 because we've calculated for 3. So it will be n combination from this formula, n combination x. Your n is what? Your n is 5. Your x, I said it will always be given. So it's 4 from the question. And then your p is 0.2. Your x in this case is 4. And then your q is 0.8. And then n is 5. You subtract 3. And then you punch this on the calculator as it is. 5 combination 4, I showed you how. You press 5, you press shift, you press division sign, and then you press 4. You close the bracket, and then you open another bracket, 0.2, you close it, and then to the power 4. Open another bracket, 0.8 inside the bracket, and then 5 minus 3 as their exponents. You get the answer. What is the answer? Salda, what is the answer?
Zero
0 point?
Answer is
The answer is
0.0.
the answer is
yes.
0.00.
the answer is 0.0064.
So you all got 0.0064.
0.00.
Yes.
Okay. I hope you understand. So you take this answer, 0.0064, you substitute it here, 0.0064 plus probability of x equals 5 here. You do the same. No, let me not do this. You do the same, Michael, plus, or let me take this plus sign here, plus. So you are going back to that. You don't erase anything on your calculator to save time. If you have time, yes, you can start from scratch. But to save time as a mathematician, you just change the value of x here. And then you put 5. But remember, we don't write a number on top of a number. And then here you also write 5.
0.00.
And then here your x is also 5. Here your x is also 5. And I made a mistake in the previous example. Here you were supposed to have 4 instead of 3. Are we together?
Yes.
Did you notice that mistake?
Able.
Yes, it was supposed to be 4. Okay. But then now we are changing the values of x. So you only change them. It means that you will have 5 here, 5 here, and then 5 here, and 5 here. What is the answer?
0.000. 4 zeros.
4 zeros.
32. No. No. 32.
How many zeros? 0.0.
0.000.
Yes.
32.
32. And then you write it here. 0.0032. No.
000.
Right? 0.00032. I get. And therefore you are going to add all these probabilities. Then that will be your answer. Are we together? So your answer will always be between 0 and 1. If you don't get an answer that is between 0 and 1, both inclusive, it's wrong. Are we together? So
Able.
I hope you understand the last one. The last one, not more than 2. What does it mean? Not more than 2 qualified persons. Probability of x, not more than 2. What does it mean? Not more than 2.
Less than.
Equal or less than 2.
Good. Equal to or less than 2. The reason we can't just say less than is correct is because they are saying not more than 2. It means that they are saying you can either get equals to 2 or less than 2, but you are not supposed to get more than 2. Is that clear? Not more than
Yes.
2 means you get something that is not more than 2. But if it's equal to 2, we don't mind. If it's less than 2, that's what we want. We need less or equals to 2, as long as it's not more than 2. I hope it's clear. I get. And you
Yes.
can also use an alternative for what we have calculated before. I get. For this one, for at least 3, you can use an alternative. So the alternative for this one will be, again, it was probability of at least 3. And then you can use the alternative 1 minus probability of x. What will be the alternative of at least 3?
Less than
Less than 3. Good.
or equals to
No, it cannot be less or equals to. There is equal to on the left. So on the right, we are not supposed to have it. If on the left we don't have
okay.
it, we are supposed to have it on the right. So not on both sides. I get.
Okay.
So if you want to put it in another way, you say 1 minus probability of x less or equals to 2, not less or equals to 3. So the reason I'm avoiding using different numbers, so I don't introduce the method that was taught to you by mem in class, because it will confuse you. Again, so I prefer using the same numbers. If I had 3 on the left, I also use 3 on the right. So that one you will never go wrong with. Again, so this one of using different
Okay.
numbers on both sides, it will confuse you. So the alternative for this one, as I have said, so you will have this. So you have 1 minus probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2. Then this will be your last value. So if you use this method, you will calculate the probabilities of each x value separately, the same way we did with the previous example, and then you will get the same answer. You take the answer for these ones in bracket, you subtract from 1. You will get the same answer as that one which we got. Okay. So now we are calculating for what? For at most 2. So it means that they need probability of x equals what? 0 plus probability of x equals 1 plus probability of x equals 2. Then I don't think you will fail to do this. You follow the same procedure. You calculate for x equals 0. You go back to that formula. This formula, and then your x here will be 0 for the first one, 0, 0. And then you calculate for 0, 0 here, 0 here, and then 0 here, and also 0 here. And then you get the answer, right? So you will also go for 1. You also go for 1. You will get the answer again. That answer, don't forget to take it here. You come and substitute that answer here. If it's, for example, 0.1, you write 0.01 here, if it's 0.0.1. So plus probability of x equals 1. You go back to that formula. So you change the value of x. Even on your calculator, you don't cancel everything. So it's just a matter of changing the value of x. So it's 1, 1, 1, 1. And then you calculate, right? For 2, you do the same. And then after calculating, you take the number that side. Then when I say that side, I mean here. So you take the answer you got, you put it here. Y plus, and then you calculate for 2. So you come back to the formula here. So you change the value of x again only. And then you will get 2, 2, 2, 2. and then you will get the answer. You take that answer, which is your Z, and then you substitute it here, plus Z. So at the end, you get a value that is between 0 and 1, both inclusive. Are we together?
Yes.
So I hope you all understood, right? So this will be the end of our session if you don't have questions. Do you have questions? Do you have questions? I suggest you guys go and practice the signs and terminologies using probabilities. At most, at least, not more than, not less than. And also practice more on alternatives on how to change the signs. That is very true. That is very true. They are supposed to do so. So you can see the message in the chat room, right? Please do as requested. Are we together? So you don't have questions, you don't have comments? And be informed that next week we are going to give you a test. So we'll give you a mini test you write based on everything we did. The probability distribution you write, and then we assess, we give you the marks. Those who are attending contact lessons, I told them clearly that next week they are going to write a venue-based quiz or a mini test. They write, we mark it, I give them the answers right there. If you get 0, I expose your result. I'm trying to do this so that you go and study. You don't take this for granted. You study and make sure you are prepared for everything, because if you fail, you get 0, I expose you, and I even tell other students to laugh at you in class. So they will laugh at you because you would have got 0, and then your self-esteem would be lowered and you will be negatively affected. Are we together? So don't just multiply our effort by 0. Make sure you go and study, prepare for your tests, prepare for your exams, prepare for your quizzes, so you will get distinction. Are we together?
Yes.
Thank you. Colleagues, is there anything you would like to say? I can see Dr. Paola was here. I can't see him anymore. And Z is also here. And then Tep, is there anything you would like to say? Dr. Paola is there.
Yes.
Yes, you can talk.
Yeah, I want to say one thing here on the issue of the test. Please, guys, don't run away and say you are afraid of being exposed. Please come and write. We want to check how far are you in preparation for the main test and the exam. So yeah, guys, please come and write. If you fail, don't worry about exposing. We are trying to build you.
Yes, that is indeed true, and thank you very much for the golden words of encouraging them. Yeah, the essence of giving them a test is to actually identify the potential challenges they are facing. So once they write, we mark their scripts, we are able to see that, okay, these students are finding a difficulty when coming to doing this and this, then we are able to strategize. I can see Tepi saying he doesn't have anything to say. Dr. Paole, do you have anything to say? Okay, he also has nothing to say from his side. Okay, ladies and gentlemen, in the absence of questions, comments, or addition, subtraction, multiplication, let's call it a night. Blessed night to all of you. May the angels of God protect you in all the angles and all the spheres of the earth. Thank you very much for attending.
Thank you for your time.
Bye.
Sibonga futhi.
Risalvalo or sendela a recruiting to group, please.
Okay, we will do so. But if it's long, it means that we will just upload it on YouTube and then you will watch in your leisure time. I get, because if it's long, it won't be sent in the WhatsApp group chat.
All right.
So after uploading on YouTube, we'll make sure we send you a link and then you just go and watch.
Okay.
Sure.